Hey guys, I'm Alexander and welcome back to my channel. If it's the first time you are subscribing, please remember to click on that bell icon for more upcoming videos. I have the utmost respect for these guys. They are from Future Energy, a local company in my country, but their headquarters is in Egypt. And they let me talk along today so I can give you a full overview of setting up a solar system. And they're going to put a 5K solar system on this beautiful house, and I'm going to document it all and show you what I can show you. They said I cannot show everything, but I'm going to show you most that I can show you and explain it to you while we go along. And such with anything in life, it starts with a plan, and with a plan it starts with some mathematics. These guys, I'm going to math it out to let you know how the distance between panels, rails and tilt leg, how they're measuring it. And that is what the first thing they're going to do. Figure out where south, east or west is from. We paint our panels south facing, and so once we figure out where south is, we start to measure on the roof where the panel is going to be placed. And this is what they're doing now. These backs are the standing seam brackets. These brackets will clip on the zinc hen and they will bolt down on both sides. See it in a moment here. So here, as you can see, as you can hear, they're going to start right here. So the first leg is going to drop right here. See, you just straighten it up and use it have clipped to the lip of the standing seam very strongly. With all the bracketing and mounting on the roof, it's a beautiful sight of clamps and hedge of all zinc. We now move to the hell feet. These aluminum steels are called hell feet, and they are locked right on top of the brackets to give it a more strength to hold the rails. And you're just going to go along and do them all over again. You put on a hell foot and move on to the next one, just like that. I mentioned the standing seam are the more new type of zinc that coming out, and they're easy to work with. I've told that they're solar guys, they love working on these because they're just easy to work with. So now you can see all the L feet or hell foot are mounted properly on top of the now it's time to move to cutting and sizing all the rails. So these are the rails. They are aluminum sheeting, well thick and durable. Once all rails are cut to specific size and specific length, you now join them together. Two rails together, you join them. So they are joining the rail. So once you put on the air foot on the rail and the C-clamp holder, so as you can see right here, this is 3 components. First, this one, and this is the L foot. These are the S5 clamps for this type of roofing. Once you have put on that, and this is the L foot, these are the rails. So the next step from here would be the panels. With the sun fastly going down in the distance, we have to call it a day this day and start fresh tomorrow morning. To recap, we have shown you lining south facing the panels, measuring the distance between L feet, measuring the distance between rails and panels, mounting L feet, S clamps and rails to complete the day. So we'll start fresh this morning by mounting the panels. These panels are monocrystals, and we're going to mount 18 of them on this roof. They're 280 watt and 8.9 amps. These are the mid clamp, and they're very unique in design, because they groove into the panel edge. That means when you tighten them, they have gripped the panel. So when you're grounding your panel by the rails, you only ground every other rails, because each of these mid clamp already ground each panel for you. This is our first engagement with any type of wiring, different from the back of the panel that have positive and negative. This is the PV wire, 6mm. We have it in red, we have it in red and black. This is also a MC4, negative and positive. This end is going to go on the panel and go downstairs to a junction box. While we finish up mounting, racking, wiring of the panel, we're doing our final by grounding the panel. Also bring it down to this junction box that the guys are working on right here underneath attic. Instead of boring the roof, we're going to use a conduit to bring all the wire from the top of the roof down to the junction box, and from the junction box inside of the attic to inside of the car garage, and bring the ground pipe straight down to the ground, take a hole, put the ground spike in and label it. This is the copper wire that is going to be the ground wire. It's also the wire that's used to ground each rail on top of the roof. Notice the perfect junction box to bring all the wire inside. This is the fitting for the conduit to transfer the wire from the solar panel to the attic to go inside the garage. Flex conduit. It can sustain a longer time in rain and sun. That's why I use the flex wire. The wire coming off the roof with the ends of the MC4, the black and the red. So here we have 5 wire coming in from the PV and we're outside. 2 black, 2 red, and 1 green. Coming down into a conduit, plastic conduit, going to the inverter. That's the DC side. Growing the system, make it more efficient. So this is a Sunny Boy inverter, 5000K. To the right, it is an ATS. Now the function of the ATS is to distribute current to the house. So the utility comes in this box, the generator comes in this box, and now we're going to put the AC side into this box. So this is the main control for the house. Even though there's a breaker box, this is where all utility comes. Wiring up the inverter AC side. Standard red, green, black, and white wire. This is the breaker box for the house. There's no need for us to connect anything in this panel because everything is going to the ATS. And ATS feed this box. So this little small box right here is like an emergency switch off. So it's disconnect the inverter directly from the ATS. In case of fire, you can just switch this converter right here and it disconnect the inverter from the ATS. So no damage caused. This is a point where if you're not comfortable working with electricity, do not connect your own inverter into the ATS. Get a certified electrician to connect into the ATS because you will be working with live current. See, the inverter is connected. Red, line 1, black, neutral, and white, line 2, green to ground. So the only step left is to go over to the DC side and make that connection to the white button pushed in from both sides of the roof. So some final adjustment for the DC wires to enter into the inverter. This is DC wire that's coming off the roof. If you notice, there is 2 red, 2 black, and 1 green. We call these strings. So it's 2 strings. So the first set is line A. 1 black, 1 red. Line B, also 1 black, 1 red. The green wire for the ground will be bolted to the pan or the inner housing of the inverter. And with a few touch up, make the wire look good inside and look presentable. Close the inverter cover, make a final check to see if everything connected right, and the only thing left to do is to turn it on. But of course, the owner of the house have to go through the process of applying for a meter, because as I said, this is a good time. It's going to take him a while for him to get his meter, so he can use the inverter till his meter arrives, till his thing gets inspected. Once the inverter is closed and we are satisfied that everything is connected properly, voila, and we turned on and the inverter is working properly, and you can see it's light up. On a whole, I would say it was a successful installation. The team have hard work itself over the last 2 days, and it was good, if I might say so myself. Now if you think it was a good build, please like, share and subscribe. Leave your comments. Let me know if you have missed anything and there's something you want to correct me. I like when you guys comment. Please don't forget to subscribe.